Welcome to the second half. In today's lecture, we are talking about bubble sort algorithm. In the first half of this lecture, we discuss theoretical background of the bubble sort algorithm, and then we saw how bubble sort algorithm sort the data which is in unsorted form or give it a logical order. We considered some general examples. We saw a beautiful dance video, animated video about the bubble sort algorithm. And we also studied the pseudocode of the algorithm. And now it's time to practice or give a dry run to the algorithm. Okay, for that purpose, I'm going to rely on a digital gadget, which is a pen tablet, and I'm using a live board. But this is my first time that I'm using to practice such things, so maybe the writing is not perfect, or maybe some bad things happen during the lecture, so sorry for that in advance. Let us start. Let us take an example of array which is in unsorted form. It's a bit panic, but I will handle, no problem. Okay, so we have an array and the elements of the array are 20, 10, 40 and 30. Let us give it a name. So here the name of the array is A. Index is first location, second location, third location, and fourth location. Okay, step number 1 of the algorithm. I'm sorry I would not be able to display the algorithm right now, but if you want, you can have the algorithm in front of you. It's in the slides. So step number 1. We have a for loop, and the name of the variable in the loop is pass. So the value of pass is, the initial value is 1. Pass is less than or equal to n minus 1. Now here the value of n, we know that n is equal to 4, total number of elements in the array. So 4 minus 1 will actually give you 3. And then for loop, so we need to increment the variable pass plus plus. Okay. Okay. So let us take the variable 1 is less than 3 or equal to 3. If the condition is true, which in this case is true, then we have to move to step number 2. So here the condition is already true, 1 is less than 3. Then go to the second step. In the second step, we have a variable inside the loop, which is the inner loop. The initial value of this comparison variable is 1, and the final value is comp is equal to n minus 1. So n again is 4, 4 minus 1 is 3, and then comp plus plus. Okay, let us check the condition. Here we have a less sign as well. We have a razor as well, don't worry. Where is the pen? Okay, comp is less than or equal to 3. Got it. So now put the value of comp, which is 1. So 1 is less than or equal to 3. Yes, the condition is true. So now we have to move to step number 3 of the algorithm, which will execute it only if the condition is true. In this step, we have to do the sweep. The sweeping process will happen here. Give me a minute, please. Okay, so now we have to move to step number 3. In step number 3, we have to check a condition, and the condition is like this. If A of comp is greater than A of comp plus 1, if this condition is true, then we have to interchange the two values. For interchange, we need a third variable, and the variable that we are going to take is temp. So I'm going to write the variable here. The value of pass is, the current value of pass is 1. The current value of comp is also 1. And the value of temp is going to be, we are going to take the value of temp from here. And the size is 4. So let us give temp a value. First check the condition. A of comp mean A of, the value of comp is 1. So A of 1 is greater than A of comp plus 1, and the value of comp plus 1 is 2. So check the condition. A is greater than A2. Yes, condition is true because 20 is greater than 10. Then interchange them. For that, we need to assign temp the value of A comp A1. So there is 20. Now you see the value of temp is 20. We have actually assigned the value of A1. So this is A and this is 1, and the value here is 20. So 20 will be assigned to temp. In the next step we have to assign the value of A comp plus 1, that is A2, to A1. So you can say that A of 1 will be equal to will be equal to 10. There is A, there is 2. The value of A of 2 is 10. So assign this to A of 1. And then finally you have to assign A comp plus 1, there is A2. Assign the value of temp to A2. So the value of temp is 20. Actually what is happening here is that we are swapping the two values because they are out of order. If you have difficulties in understanding the steps, please place the algorithm in front of you and then follow the instructions in the algorithm, and you will see that we are on the right path. So at the end of this pass, we have to swap these two elements with one another. This is the first step of the algorithm. Let us move to the next step. I will add another page. It's page number 2. load it. Okay, now let us start the second phase of the algorithm, the second pass of the algorithm. So now the array that we have after the first form is like this. My drawing is getting better and better. So we have swapped the first two elements. After swapping, the position of the elements is like this. This is the same array, but the algorithm has actually swapped the first two elements. The name of the array was A. Is first, second element, third element, and fourth element. The size of this array is 4. Now we have some variables inside the loop, and they are pass and comp variable. Let us start with step number 1 of the algorithm. Okay, so we have two loops, outer loop and inner loop. In the outer loop, the variable pass has the value 1, but for this one we have to execute this loop n minus pass time, which is 4 minus 1, that is 3. So 3 times. The previous value of comp was 1. After swapping these elements, we have to increment the value of comp by 1. Now the actual value of comp is going to be 2. In the for loop second step of the algorithm, the value of comp has been incremented by 2. Okay, so now we have to go to step number 2. So here the value of comp will increment by 1. The new value of comp variable is now 2. Okay, check the condition. 2 is less than or equal to 3. Yes, 2 is less. So the condition here is true. That is why we have to execute or move to step number 3. In step number 3, we have to compare the adjacent elements again, right? But this time not A1 and A2, but A2 and A3. For that, we have to put the values here. So in step 3, if you see the algorithm, the value, the step is like this. A of comp is greater than A of comp plus 1. If it is true, then execute the following statements. So let us see the value here. A of comp, that is, the value of comp is 2, so put 2 here, is greater than A of comp plus 1, that is 2 plus 1 is 3. So if you see the values, A of 2 is 10, sorry, A of 2 is 20, and A of 3 is 40. So check. A of 20 is greater than 40? No, it's not greater. So there is no need to sweep and no need to execute further. Then you have to go back to the inner loop, return to step number 2, right? So here we do not sweep the elements, but we need to increment the comp by 1 now. So let us move to the next page. Okay guys, the array is in the same, the elements of the array are in the same position. It is 10, 20, 40 and 30. So now we have to increment the value of comp. The previous value of comp was 2, but it will increment in the loop, so the new value will be 3. And then in step number 2 you have to check the condition in the for loop. 3 is less than or equal to 3. 3 is less than or equal to 3 is not less but equal, so the condition is true here. If the condition is true, then you have to move to step number 3. Again we have to compare the adjacent element, but now element 8 location 3 and element 8 location number 4. We need to compare them, these two elements, or the algorithm will compare these two elements. So if a of com, that is a of 3, is greater than a of com plus 1, that is a of 4. Oh, the 4 is not recognizable. Let us change. Yeah, better now. The value of a of 3 is 40 and the value of a of 4 is 30. So 40 is greater than 30. Yes, now it's time to swap them. For swapping we need a third variable, and that variable is temp. So temp is equal to, okay, we have to assign the value of a of com to temp. Here a of com is a of 3 and that is 40. So 40 will be assigned to the variable temp. Right, so temp is equal to 40. Next, you have to assign a of comp plus 1 to a. So this is a of comp and the value of comp is 3. So assign a of comp plus 1 to a of 3. That is a of 3 plus 1 is a of 4. What's happening here? I think I need a fleet object for making gadget more useful. Anyway, okay, so the value of a of 4, if you see at the array, is 30. So assign 30 to this location, which means things are going to be like this: 10 at its own location, 20 at its own location, but a of 3 will now contain 30. The previous value will be overwrite, and then we have a free space here. It is a of 4. Okay, now assign a of com plus 1, that is a of 4, the value of temp, variable temp. So as you see, we have 40 in the temp. Assign it to F4. This is 1, 2, 3, 4. So 40 will be assigned to this location, right? Now last thing, after execution of this step, we have to go back to step number 2. Again, we have to increment the value of com by 1. Now the new value of com is 4. Check the condition. 4 is less than or equal to 3. 4 is less than or equal to 3. Let me select the pen. Is it true? No. The condition is now false. So when the condition is false, there is no need to execute these statements. These are inside the body of the for loop, so they will not be executed. And then it's time to move to the outer loop in step number 1. And there you have to increment the value of pass by 1. That is considered to be the second pass. However, this is the end of first pass. If you see, the largest value, which is 40, is bubbled up to the last location of the array, which is in sorted form now. Then you have to repeat the same process for the rest of the element. One more thing to remember. If you see at the list now, the list is already in sorted form. But still the algorithm will be repeated. The iteration will occur, the comparison will occur. There will be no swapping, but the elements will be compared with one another. And this is one of another drawback of the bubble sort algorithm, that although the array is in sorted form now, but still the algorithm will repeat its process. So there is something which is not very recommended, because the array is sorted now, but still the algorithm will continue and will do the comparison. So this was about the dry run of the bubble sort algorithm. Now it's time to move to the analysis portion of the bubble sort algorithm. Let us see it. Okay, so we have give a dry run to the algorithm, and now it's time to study the analysis, to analyze the performance of this algorithm, bubble sort. While analyzing algorithm, we can consider different matrices like memory, bandwidth, easiness of the algorithm, number of times the statements are executed. So we actually consider a model which is called the REM model, and we talked about the REM model. According to that, we give importance to the running time of the algorithm. And again, running time, there are 3 cases for calculating the running time of the algorithm. The first one is the worst case analysis, the second one is the average case, and the third one is the best case. Worst case actually refer to the condition, to the case where the algorithm will require the maximum amount for execution. Best case is the opposite, in which the algorithm require the less amount of resources for execution. In searching, I told you that the worst case in searching occurs when the element for which you are searching is present at the last location in the list, or the element is the worst case happen when you are searching for an element and the element is not present in the list, or it is present in the list but it is at the last location. So that is going to be the worst case, because you have to compare the item, the key value, with each and every element of the list. For example, if we are using the sequential search. Similarly, I mentioned that the best case happen when the element for which you are searching is at the first location in the list. So you will be able to find the exact location or element just after doing one single comparison. So that is going to be the best case. An average case is actually very difficult to calculate, and it is not reliable. It actually depends on the possibilities, probabilities, and input, etc. So normally for analysis of algorithm, we prefer to find the worst case analysis of any algorithm. Best case is also possible, but we are more interested in the worst case scenarios. So let us see the worst case analysis of the bubble sort algorithm. Actually, if you give attention to the bubble sort algorithm, you will come to know that the basic operation of the bubble sort algorithm is related with the comparison between the elements, and the second thing is the swapping of the elements if they are out of order. So the analysis of bubble sort algorithm, we have to consider these two things, comparison and swapping. So here is the worst case analysis of the algorithm. In the worst case, you could actually see that our algorithm consider the number of comparisons. And if you revise the concepts in the bubble sort, we actually do n-1 comparison in the first pass, we do n-2 comparison in the second pass, and we do n-3 comparison in the third pass, and so on. So the total number of comparison will be the addition of all these comparisons. So n-1 plus n-2 comparison plus n-3 comparison, and then gradually the number of comparison are decreases one number at a time. So finally you will do only a single comparison, that is the first two adjacent elements will be compared in the final step or in the final pass. So it will give you an equation that is n into n-1 divided by 2, that is equivalent to n-1 plus n-2, that is the basic summation equation. If you multiply them, you will get n-2 and minus n divided by 2. So if you remember the rules of analysis, we have to consider only the dominant factor. Here we have n square and n, but we have to consider only the n square. And also we need to ignore the constant, the leading constant, if any. So you can also ignore 1 by 2 or 2, whatever it is. And then what will left is n square. So big O n square is the worst case running time of the bubble sort algorithm. Let me tell you one thing, that different ways are there to analyze the bubble sort algorithm. This is the most simplest way and most easy to understand way to analyze the performance of the bubble sort algorithm in worst case. So in worst case scenario, or the worst case scenario occur if the array which is given is in a reverse order. For example, the array is in descending order and you are asked to sort the data in ascending order. So in this case it will do the maximum comparisons and it will actually do the maximum number of swapping in the worst case scenario. So in that case we are aware of the situation that actually in worst case or in the bubble sort algorithm, in the first pass we do n-1 comparison, in the second pass we do n-2 comparison, and then n-3 comparison, n-4, and then we gradually reduce the number of comparisons, then we reach to 3, 2 and 1. So this is a summation equation, and that is equal to n into n-1 divided by 2. So if you consider the leading term here, which is the n square quadratic, so the running time of the bubble sort algorithm in worst case is n square. In the beginning I mentioned that it is a good algorithm for small data, but it is inefficient on the large data, and you can see it from here. What you see is that it has a running time of n square quadratic. So if you remember, the best algorithm are those whose running time is in the log of n. But here we have the running time in n square, which means it will increase, the running time will increase rapidly if we increase the number of inputs, because it has a relation with the number and types of input. So the worst case analysis will give us n square. Let us move to the best case analysis of the bubble sort algorithm. For best case scenario, let us take an example. In this example, we have an array which contains 3 values, and our task is to sort them out by using the bubble sort and then find the complexity. If you give attention to the values, they are already in sorted form. 1, 2, 3 is in ascending order, but still the algorithm will do its task. Swapping will not occur, but comparison will occur. So first thing first you have to compare the first two elements, the element at location number 1 and the element at location number 2. So compare 1 with 2 and swap them if they are out of order. After comparison, we get the idea that they are already in sorted form. So there is no swapping because 1 is less than 2. Then in the second step, again the same values, the algorithm will now compare the next two elements, that is the element at second location and the element at third location. 2 will be compared with the 3. So 2 is greater than 3. No, again no swapping will occur because the elements are already in sorted form, in ascending form. So 2 is less than 3, no swapping will occur. Since no swapping are done or occur, we are done. And we saw that the algorithm only did 2 comparisons for n is equal to 3. We can see that if we have n elements, this algorithm best case will take only n minus 1 comparisons. So here's the time complexity of the bubble sort algorithm in the best case analysis is n, or you can say capital O of n. So this was the best case analysis of the bubble sort algorithm, right? Okay guys, this was about today's lecture, and in today's lecture we actually covered bubble sort algorithm. We start with the general background of the bubble sort algorithm, the technique used by the bubble sort algorithm, how it sort out data. We saw a general example about the bubble sort algorithm, how it sort out data, the algorithm, the pseudocode of the, and then a dry run, and finally we saw the analysis of the bubble sort algorithm in worst case and in best case scenarios. So this was about today's lecture. We will discuss another topic in the coming week. By the way, let me tell you that you have an assignment due for the next week, and I will share the details about the assignment on the course website. Till then, goodbye.